Hi there. So today we will be solving some previous year JEE questions of quadratic equations. Quadratic equations. So we have this question from JEE 99 and it says that x square minus 2ax plus a square plus a minus 3, its roots are real and less than 3. So we have two conditions that the roots are real and are less than 3. So if we say that its root will be alpha, say alpha comma beta are roots, it will be 2a plus minus root of 2a whole square minus 4 into a square plus a minus 3 upon 2. I have written this by using b plus minus root d upon 2a. Here a is 1 and b is 2a and c is a square plus a minus 3. So if I solve this, or rather simplify it, then it comes out to be a plus minus root of what is it? 4a square and 4a square got cancelled and we left with 12 minus 4a, and we have this 2, so we got a plus minus root of 3 minus a. Now this is the root, either the plus 1 or the minus 1. So they are saying that this is less than 3 and the root is also real. So the condition for real root is d should be greater than or equal to 0. So 3 minus a should be greater than equal to 0, which says that a should be less than equal to 3. So this is the condition 1 we got from real roots. And the one says less than 3 is this one. So if we move this a to this side, we get plus minus root 3 minus a is less than 3 minus a. Just square both sides, we get 3 minus a less than 9 plus a square minus 6a, which implies a square minus 5a plus 6 is greater than 0. And if we simplify further, we get a minus 3 into a minus 2 greater than 0. Now if we draw the axis line and mark the points 2 and 3 on it, if a is greater than 3, this is plus. If a is less than 2, this thing is also plus, but in between 2 and 3 it is negative. So this condition implies that either a is less than 2 or a is greater than 3. But we have to neglect this thing as this is one of the conditions for real root. So it should be a should be less than 2 is the answer. We have got this option as the answer. Okay, so you have to take the condition for both things. First the real and the second one is less than 3. Now we have this question from REE, that is Rookie Engineering Exam from 2000, and it's a good question. So the question says that if the roots of this quadratic equation are alpha and beta, and we have to find the roots of this equation. So first we will be looking at this equation. If we simplify it, or rather expand it, we will be getting x square minus a plus b into x plus ab plus c is equal to 0. Its root are alpha and beta. So this implies alpha plus beta is a plus b and alpha beta is ab plus c. We have written this thing from sum and from product. Okay, but if we use this equation, so if we expand this equation, we get x square minus alpha plus beta into x plus alpha plus plus alpha beta is equal to c. Now just put these values and you will get x square minus a plus b of x plus ab plus c is equal to c. Now this c and this c got cancelled and we are left with this equation. Plus ab is equal to 0. Now observe that its roots are a and b because the sum is a plus b and product is ab. So we have got the answer as a and b. So we have done this question also. Now we move on to this triology, that is 3 questions from JEE 2000. And the first question says that for this equation, one of the root is square of the other and p is greater than 0. So the solution for a part is let roots be alpha and alpha square. So from the sum condition, we got alpha plus alpha square is minus p by 3, and product condition we get alpha into alpha square, that is alpha cube, is equal to 3 by 3, that is 1. Okay, now just look at this thing. Now we have got this thing, alpha cube is equal to 1. The first thing that runs in our mind is that alpha is equal to 1. Okay, but if alpha is equal to 1, then alpha plus alpha square would be 2. 1 plus 1 square is 2. That would be equal to minus p by 3, which gives us the value of p is equal to minus 6. But the question clearly says that p is greater than 0. So there must be some fault, and the fault lies here. This is not true, necessarily not true. So just move this 1 from here and you will get 1 cube. Alpha cube minus 1 cube is equal to 0. We write 1 as 1 cube. Now use the identity of a cube minus b cube, that is equal to a minus b into a square plus b square plus ab. This identity is very useful and you should learn this. So by applying the identity we get this thing. Now we have seen that a is not equal to 1, so we cancel this case and we are left with this thing. So if the multiplication of this and this is 0, so either this should be 0 or this should be 0. But we have eliminated the case that when alpha is equal to 1, so we are left with alpha square plus alpha plus 1 is 0, which implies alpha square plus alpha is equal to minus 1. Now put this value in this equation and you will get as minus 1 is equal to minus p by 3, which implies p is equal to 3. So we have got the answer as p is equal to 3. Now we have the second question as this. So it says that we have x square plus bx plus c is equal to 0 and c is negative and b is positive. And we also know that beta is greater than alpha and beta are its root. So the b part, solution of b part I am doing here. So solution is, we know from the sum condition that alpha plus beta is equal to minus b. As b is positive, so minus b is negative. This implies alpha plus beta is less than 0. First condition, we say it as first condition, and second condition is alpha beta is equal to c and c is less than 0, so it is also less than 0. So it is second condition. Now look at the cases. What can be the possible cases that alpha is positive and beta is positive? First case, or alpha is positive, beta is negative. this is the second case, alpha negative, beta negative, both can be negative, and alpha is negative and beta is positive. So these four cases arise. Now we can cancel this case, like we can eliminate the first case, because if alpha and beta are both positive, then both the sum and product should be greater than 0. So we eliminated this case. If alpha is negative and beta is negative, then alpha into beta should be positive. So we cancel this case also. Now we are left with this case or this case. But the question says that beta is greater than alpha. So this case is also eliminated, because a negative number can't be greater than a positive number. So now we know the signs of alpha and beta. We know that alpha is negative and beta is positive. Now look at this condition. If the mod of alpha, the mod means that only plus value. Mod of -4 is +4. Mod of 4 is also +4. So the mod returns always positive value. So we know that alpha is negative, but mod alpha will be positive. Okay. So the value of mod alpha will be less than beta. Why this thing is true? Because what can be the other case? Other case can be mod alpha is greater than beta. This can be a case. But if this is the case, then beta plus alpha is less than 0. This is not the case. So till now we know that alpha is negative, and we are considering the possibility that whether mod alpha is greater than beta or less than beta. So if mod alpha is less than beta, then beta plus alpha must be greater than 0. For example, beta is 6 and alpha is say -4. Then beta is greater than mod alpha. So this is the case. So 6 minus 4 is greater than 0. So this cannot be the case, and we are left with only this case. So the answer is, we got the answer as B part. Now the C part says that if B is greater than 0, B is greater than A, and this is the equation. Now we have to tell whether the roots lie in which condition or so. So if we do this question, C part, B is greater than A, and the equation is x minus A into x minus B is equal to 1. Okay, so this is the question. Now just look at this thing. First of all, we will be opening this equation. So it will be x square minus A plus B x plus EB minus 1. Okay, so if I write alpha and beta, then alpha comma beta would be A plus B plus minus root of A plus B whole square minus 4 into AB minus 1 upon 2. I have used the formula of alpha comma beta can be written as B minus B plus minus root of B square minus 4AC upon 2. Okay, so minus B is A plus B in this case. Now just open this. We will be getting A square plus B square plus 2AB minus 4AB plus 4. It can be written as A square plus B square minus 2AB plus 4, which indeed can be written as A minus B whole square plus 4, and the whole thing becomes root of this thing upon 2, and we are left with A plus B by 2, this thing. Okay, now I am saying that this part is always greater than equal to a minus b upon 2. Why? Because of this 4. If we like say this 2 and this 2 got cancelled and you will square, you will get that this thing is always greater than this thing. So we know that alpha comma beta will always be greater than a plus b by 2 plus minus a minus b by 2. Okay, now the question has ended. Why? Because if we draw the x, say the axis, and here it is a, here it is b, and if we mark a plus b by 2, which would lie somewhat around here, now this thing alpha comma beta is this thing, suggests that alpha plus, if alpha is the plus sign and beta is the negative sign, then alpha is a plus b by 2 greater than, that is the greater sign, plus a minus b by 2. So it suggests that it is, so alpha is the, say alpha is the negative sign and beta is the positive sign. Okay, so it suggests that one root is greater than this thing, greater than b, and one root is less than a, less than a. Okay, so it is a plus b by 2, and this difference, what this difference is? This difference is b minus a by 2. Okay, so we have done this question and the solution is D part. Now we move on to the last question for this video. This is the question. It appears in JEE 2000 and the question is good, that says that this is the quadratic equation and its root are alpha and beta, and this quadratic equation has root alpha plus delta and beta plus delta. Now we have to prove this thing. Just look at this thing. If I say ax square plus bx plus c is equal to 0, we know some condition that alpha plus beta is minus b upon a, and the second condition we know that alpha beta is equal to c by a. If I square the first thing, we get b square upon a square, that is alpha square plus beta square plus 2 alpha beta. Okay, so we are now here. Now subtract 4 alpha beta from both the sides. We get alpha square plus beta square minus 2 alpha beta is equal to b square upon a square minus 4c, because alpha beta is equal to c by a, so 4c by a. Okay, the LHS becomes alpha minus beta whole square, and this is b square minus 4ac upon a square. Okay, so square root both the sides, we get alpha minus beta is equal to plus minus root of b square minus 4ac upon small a. Okay, now this, what is this? This is the difference of roots, and its value is equal to plus minus root of capital D upon small a. Now just apply this formula in this equation. How we can apply this formula? Its difference can be written as alpha minus beta, and this difference alpha plus delta minus beta plus delta. So it is a bracket. We get alpha minus beta. So both the roots have the same difference. So this can be written as root of small d by a, that is this d, b square minus 4ac upon small a root, and this difference can be written as the d of this equation, that will be capital B square minus 4 into capital A into capital C upon capital A. Now we know that the difference are same, so this must be equal. Now square both sides and you will get the answer. So the formula for this question, which you have to remember, or say you know this thing, it is asked many times and it is important also. So in the next video of this series, where I will be solving some problems from previous year, I will do questions of quadratic equations also.